You are welcome to today's class. Today we want to look at introduction to arrays. So what is an array? An array is a data structure, right? So but how do you define it? So I will say an array is a collection of elements of the same data type stored in a contiguous memory location. That is an array. What do I mean by that? This is how a memory is created, right? You have this, then you have this, 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 you have this. So an array is a collection of elements of the same data type stored in a contiguous memory location. Now, why do we need an array? Before I answer that question, let me explain how variables are stored in the memory, right? Now, let's say I declare a variable int a. This is a variable. That is the variable name, right? Variable name a. And then this is the data type, which is like the RAM. The last class, I taught you storage classes and variable scope. That was what I taught you in the last class. So in this class, I'm going to teach you array. But to explain this array, I need you to understand how this memory as these variables are stored in the memory. So I declare a variable a in the integer data type. How is this going to be stored in the memory? Because this is an integer, right? What will be the size of this integer? In most computers, it is what? 4 bytes. Now, this is a memory. This is how a memory is. So in this memory, each of these is considered as what? Byte. Each of these is considered as a byte. Now, this byte has address, and it is usually in hexadecimal. But for the sake of this class, I'm just going to use generic number. So this one, I will say 100. This one will be what? 101. This will be what? 102, 3, 4, 5, 6. Let's add to it. 7. Let's add to it and make it what? 108. Now let's leave it at that. Now I declare a variable int a, and it's 4 bytes. So it's going to allocate 1, 2, 3, 4 for a. So all this 1, 2, 3, 4 will be what? Allocated to what? A. Now, if I assign a value to this a, that is int a, and I assign 5 to it, this is 5. How am I going to store this 5 in this memory? First, I will have to convert this 5 to binary. To convert it to binary is I will have 5 here, 2, then 2 go into 5, that is 2, remainder 1. 2 go into 2, that is 1, remainder 0. 2 go into 1, that is 0, remainder 1. So that will give you 1, 0, 1. 1, 0, 1 for 5. But if you are going to store it in this memory, you will store it as, let's say, we take this as a 32-bit system. Now, to store it in a 32-bit system, I will come here and I will do this. So I'm going to bring out this 4. So I'll bring out the 4. Say 1. So for a 32-bit system, 32-bit system. Now, 1 byte equals to what? 8 bits. 8 bits. Now, if I'm going to store this 5 in the memory, so I will have here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then this one will be 1, 2, 3, 4, 5, 1, 0, 1. So this is how it's going to store it in memory. So the address is what? 100. Now this one is 101, this is 102, and then this one is 103. So that is how it's going to store this A in the memory. What if I want to get the marks of students in the class? So let's say I have 3 students in the class, 3, and I have mark, say 70, 80, and 90. I can store this 70 in this place, but there is no guarantee that I'm going to store this 80, that the system will store this 80 in the next 4 bytes, which is this, and this. So there's every possibility that it can store this 80 in another location and store this 90 in another location. Take, for example, you have people coming from a particular community to the city, and they are all living in different locations in the city. And then you call for a meeting. How long will it take for each person to get to the venue of the meeting? Compared to if you have everyone from that community living in an estate, and then you call for a meeting, how long will it take for everybody to come out? So that is the concept of an array. If you have to store these 70, 80, and 90 in the memory location and they are not together, it means if you are going to add them, you will have to write a repeated program for each of them. And it will be difficult for you to use a loop to add them or to print them. So that is where an array comes in, right? That is where an array comes in. So as a data structure. So that is where an array comes in as a data structure. So I'm going to declare int A, or I'll call it mark, right? And then I do this and I say 3, and then I do this. So this is me declaring an array, and this is the data type, right? This is the array name, right? And this is the size of the array. So this is actually the syntax for an array. You use a square bracket to enter the size. So what this is saying is that I have declared an array called max, expecting 3 parameters. So that is what it means, that an array is a collection of elements of the same data type stored in a contiguous memory location. So I have that my memory like this now. So I'm having 1, 2, 3, 4. Then I have 1, 2, 3, 4. So if I declare an array, let's say 1, 2, 3, that is 4. So if I have an array, which is this, and then I have int max, right? 3. Then I assign 70, 80, and 90 to it. So that is how I'm going to declare my array and initialize it. So the first thing that the system will do is to create in the memory location, this integer is going to be what? 4. 4 integer for each of these elements. So we are having 3 elements of the same data type. So I cannot store 80.5 in this array to throw me an error. So they have to be the same data type. So I'm having the element of the same data type stored in the array. So the system will come here and it will give me 1, 2, 3, 4 for the first one, right? 1, 2, 3, 4 for the second one. 1, 2, 3, 4 for the third one. So this is contiguous. That is consecutive. Now, when I have this, it is now easier for me to use a loop to access these values. Now, I will just have my array name. So in this case, is max. That is my array name. So it's having 1, 0, 1, 0, 1, 1, 0, 2, 1, 0, 3, 1, 0, 4, 1, 0, 5, like that. So this is actually pointing to this address. That we are going to look at the properties. But this is how the system is going to create a memory location to have all of them inside. So like I said, if you have, let's say you have an estate, right? You have an estate. So with this now, in max, three max, you can access them using a loop. So why do we need an array? An array allows you to store the element using just one variable name. So you can see, I have just one variable name, max, and it's accommodating all these elements. That is what it does. And then it also allows you to use a loop, right? A loop to access the values with ease, because you are going to use, in this you are going to use index. That we are still going to look at. And then the time complexity is what? 0, 1, meaning it is the same time that will be required to access this 70, 80, and 90. So that is what an array does. So what are the variants of an array? Like this. If I say int max, right? I can say 6 divided by 2. This is still correct because this will evaluate to 3, which is what? A positive integer. If I say int max 3 plus 1, this is still correct because this will evaluate to 4. If I say int max 3 times 2, this is still correct because this will evaluate to 6, which is a positive integer. So all these variants are correct in declaring an array. So that is what I want to show you in this class, why we need an array. So in the next class, we are going to look at the properties of an array, and then we'll continue to how to initialize an array. This is actually how to initialize an array. You declare an array, data type, array name, the size of the array, and then you initialize it. Now, if I do this, if I say int max or int a, and then I do this, the system will throw me an error because it doesn't know how many, the size of the memory that will be allocated. Because now, to know the size of the memory that will be a total size of memory that will be allocated for this array, right, will be what? Will be 1, 2, 3 multiplied by what? By the size of the data type, which will be what? 3 times 4. That will be what? 12 bytes. That's what the compiler will allocate in memory space. So if you declare something like this without initializing it or putting the size inside this square bracket, how would the compiler know the memory space to allocate? So this is not acceptable, except you do this, except you declare it this way and then you initialize it. So with this, the compiler will still know that I'm using an integer and then I have only 3 elements of the array, right? So that is what I want to show you in this class, introduction to an array. In the next class, we are going to look at the properties of an array. So till we see in the next class, bye-bye.